Exercise 1, SolidWorks 2020. In this exercise, we're going to take a look at the very basics with SolidWorks. We're going to have an introduction to the interface, as well as some modeling techniques. We're going to also look at one of the add-ins known as Photoview 360. And before I get started with all of that, I wanted to just share with you the computer I'm currently using. Now, when it comes to getting hardware to run SolidWorks, it runs pretty much on any 64-bit Windows operating system, Windows 10 operating system. And so I've run it with as little as 4 gigabytes of RAM and a very slow microprocessor that's about 9 to 10 years old, as long as it's 64-bit. But it's a little bit slow on that, so I don't necessarily recommend it. Nor would I necessarily recommend what I have, even though it's very fast. It's a bit on the pricey side. I'm using a little program here called CPU-Z. You could actually Google it, and it's free. You can just download it and run it, and it tells you what's inside your computer. And it's quite nice because it actually benchmarks your computer as well. You can see here I'm running an AMD Ryzen 9, the 3950, which has 16 cores with 32 threads. This is a pretty high, I don't want to call high-end machine because they have the Threadripper, which is even higher, or some of the Xeon processors, which are much more expensive. This one I built myself, and it was around $1,500 when all is said and done. I actually went a little cheap on some of the things, like what this is telling me here. Here's the processor. The main board, I went with an Asus, and Asus motherboards are very nice, but there's a lot of good ones out there. As far as memory, I only went with 16 gigabytes. For what I do in training, I don't really need much more. On my old computer, I actually had 32, and I never really felt I used it, and so I just went with 16 this time. I'll probably update it to 32 sooner or later, but so far I haven't seen any real significant slowdown. Like I said, you could run it with as little as 4 gigabytes. Now, the nice thing about, again, the CPU-Z is that you could actually see what type of memory that you have on your computer. So if you need to update, this actually gives you this memory slot selection. Don't always trust it. It's best to open up your computer eventually and look at it perhaps, but it'll usually tell you how many slots it detects. I've seen it where it's made mistakes, though, where it said I had more slots and I actually didn't. So just be aware, and especially with laptops. So just be aware with laptops, they're not as upgradable typically as a system that you might build. All right, the graphics card I'm using is an AMD Radeon Pro WX 3100. They actually just came out with the newer series. I think it's 32, starts at 3200. Actually, I think you could get a 2200, which is even less expensive. But the 3100, 4 gigabytes of RAM on board. It's runs SolidWorks beautifully. I would recommend getting a professional card if you're going to use it for professional use. If you're just using it like for school or something, a gaming card is going to run it great for the most part. There are exceptions. You might get glitches or some things, but that's with any software. Now, here's the benchmark tool, and this just benchmarks the actual CPU performance, multi-threaded and single performance. Now, what you can do is you can compare it to other processors out there. Now, I was telling you that I actually am running SolidWorks 2019 on actually this processor right here, the A10 7850, which is kind of old. It's a bit dated. It dates back to, I believe, 2013 or 2014. And I'm going to go ahead and I'm going to hit I like to usually hit stress CPU just for a minute, let it get going, and then hit bench. For some reason, it seems that I get a little bit higher results when I do that, just by a few points, not much. But you can see it's doing the multi-threaded check here, and it's done. Now it's moved on to the single thread, and you get some numbers, and the reference processor in the purple is that much older processor, as you can see there. Now it's done. You have the ability to submit and compare, and you can compare it to a bunch of other CPUs, pretty much any CPU that's out there, as long as it's Windows-based. Now, look at this. This is really neat. You could actually go on here and look at and compare it to other processors here. Like, for example, let's compare it to an Intel. Let's see here. Here's the one of the latest and greatest, the i7-1070 700 CPU. It has 8 cores and 16 threads. You can see the single-threaded performance is a little bit higher, according to this. Whereas the multi-threaded, because there's just so many more threads, you're comparing 16 threads to 32. So that's why mine is like off the charts there. And I'm sure they'll update this CPU-Z. They update it pretty regularly, and we'll expand that bar so we can see just how far off it is. Anyhow, it's a great little test you could run on here. You could also click on About and see, like, if, for example, if, what you're running as far as Windows 10, which build you might be running, and if it's 64-bit or if it's 32-bit. Remember, SolidWorks will not run on 32-bit version. I think 2013 or 2012 might have been the last version or last release. You might want to look that up. But that would actually run on 32-bit platform. All right, so anyhow, moving along. As far as you could get, like I said, a 10-year-old computer as long as it has Windows 10 64-bit running on it, and at least 4 gigabytes. It's not saying it's going to be fast. It's going to be slow. But I've run it on some pretty slow devices. So, and it worked. Okay. So anyhow, now that we looking at this, this is the actual part we're going to build today. It's a thin-walled part, as you see. You can rotate it around. It's going to be shelled, and we're going to look at actual, like, putting in chamfers. That's the blue chamfer there. These are fillets or rounds or radiuses, they're sometimes called, but in SolidWorks they're called fillet. Okay. We're going to put in some stacked extrusions, 1 and 2, and we're going to put in this hole that you see there using what's called a cut extrude. There is a hole tool inside here, a hole wizard actually. It has all sorts of neat holes like counterbores, countersinks, pipe taps, you name it. But we're not going to go into that today. We'll probably hit that in the next couple of weeks with exercise 4. All right, so let's get started. What you want to do when you first start up SolidWorks, I'm just going to attack this so you can see what it looks like without it. And let me close this. Okay, what I recommend doing is you'll see there's this little arrow right here in the upper left corner. I recommend clicking on that, and it unfolds the toolbars. Go ahead and hit the little thumbtack there. Okay, your screen, if you just started it, it might have actually prompted you for IPS or MMGS, millimeter gram second. Depending upon what region you're in or country, it might have defaulted to one or the other. You could select it. Just so you know, most of my exercises are an actual inch. So those of you in the metric, you could do conversions, or you could easily switch it. And the way you would switch it is right up here. There's that little gear in the options menu, and you'll see system options. Now, actually, I take that back. We first want to get a file up on the screen before we do this. But the system options, usually there's 2 tabs here if you have something up. But right now, my screen is blank, so system options, you'll just see all these options. And these are global settings. Once you change them, it'll remember it for every time you open up SolidWorks. I'm going to close that. Now, let's go to File, New, and also notice there's an icon as well. I like the pull-down menus just because I could spell it out for you versus trying to describe an icon every time. I'm going to go to File, New, and you'll see that there's 3 file types: part, assembly, and drawing. Now, we're going to work on parts the first 4 weeks, and then we're going to move on the 5th week to assemblies. We're going to do what's called bottom-up assembly modeling, which is the easiest. It's just taking parts that have already been built and putting them together. And we're going to see dynamic assembly motion. We're going to have like a widget that has a U-joint in it. We're going to see how it interacts once we set it up. And there's no kinematics. There's some dynamics. It's called dynamic assembly motion. So we'll see that. That's a pretty neat little exercise, exercise 5. Exercise 6 is drawing. Now you'll notice the E, or exercise 1, 2, 3, 4, 5, 6, those are the first 6 weeks of class. So every week, if you just remember the actual week it is, like if it's the 3rd week, you should be on exercise 3. Exercise 7 actually starts after midterm, because that 7th week I would actually have everyone studying. We go through and review, and there's actually a review video for the midterm that you can watch and practice it before you take it. And then the 8th week is actually the midterm. And midterm is pretty intense. You definitely want to practice it in advance. If you have used other CAD systems, you may be able to fare pretty well through it. If this is your first time out with CAD, definitely watch the review video. It's worth it. Anyhow, and then after that, we had exercise 7, 8, 9, and we get into some pretty advanced functions after midterm. So just be aware, we're going to do some really neat stuff. Okay. All right. To show you where some of this stuff is at, I'm going to go ahead and start up Google Chrome here, browser, and you could find these things if you just go to www.v as in Victor, E-R, T as in Tom, A, N as in Nancy, U, X as in X-ray, 1.com. This will have pretty much everything you need to keep you on track with this course. Like under instructional manuals, you click on that, find the SolidWorks Basics, that's what we're working on, click on it. The SolidWorks Basics will always be in red, so just know that the buttons will always be red for the manuals, the videos, and the part files, and even the exams. So here you can see this is the training guide. There is a generic syllabus in there. Those of you taking my actual class, it is available online. Anyone around the world could take it through Elgin Community College in Elgin, Illinois. You could just go to elgin.edu if you'd like. You could sign up or register for it. You need to actually apply to go there. But anyhow, and what we're looking at is the SolidWorks Basics 120 class. It's actually 3 credit hours, and the course description, objectives are in there. This is a generic one. As I said, it's not the typical one you see, but it essentially gives you the layout of everything, the evaluation scale, the points, the course outline. Here's the week by week, what we're going to cover. All right. And so, like, for example, week 4, that would actually be exercise 4. Just be aware. The other syllabus that I'm sending out to my students actually will be less generic than this. It will actually have like exercise 1 this week, exercise 2. Because remember, after midterm, the 9th week, we're already in E7 or exercise 7. All right. And there's additional information. Now here you'll see exercises, and I need to update this. This is all, these are video links actually. You could just click on them and start the video. They're from SolidWorks 2016, so they're a bit dated. They will still work for 99% of the items. There are a few changes, but like maybe the color of an icon has changed or something, or a tool is moved. But for the most part, anyone can pretty much watch those and still get by. But I would recommend, if I have newer videos, take a look. Type in like E2 for SolidWorks 2020, and it will send you to that latest exercise. Also, I have a video here, how to make a portfolio, and that's using Microsoft Word. Okay, you could also use LibreOffice, that's free. You could download that and use that and make a very nice portfolio of all of your things that you've done in this class. The totals here, you could see the first week we have E1. It's worth 10 points. Those are 10 extra credit points, by the way, because after this, all the other points just count. They add up to 300 for your exercises, which is 30% of your grade. Then the labs that you see here, and that's the L1, L1B. Those, many of them are in the video for the exercise number, for the week number, which if you just fast forward to the end, you can watch those videos. And I really recommend, I encourage my students to try the labs first. They're actually in the book at the end of that chapter, the exercise 1 chapter. Go to the end, you'll see a drawing. There's no instructions, it's just the drawing, and that's how you build it. If you get stuck though, you can actually play the exercise 1 video, fast forward it to the end, you'll see it. Now I start to not give you videos by exercise 6 or lab 6. There's no video for that one. So be aware that you're expected by, near midterm to be able to do these things on your own. And I have students who've said, why don't I have a video for this? Well, when you get into real world, you're not going to have a video to do all of these things. So you actually have to start relying on your own knowledge that you've gained through doing all these. So that's why I recommend it. Students who I've seen do the labs, they're outstanding by the end of the course, especially if they do them on their own. And then you could go back and see best practices on how to do it. As far as best practices, I've been teaching this software for 22 years. It's I was a certified SolidWorks support person, as well as certified SolidWorks instructor and certified SolidWorks professional for core. That basically at the time they didn't have them all broken out, but I took the exams for the mold side, as well as sheet metal fabrication and the freeform design at the time. But as far as best practices, there are new functions. Some of them I try and incorporate as best as I can. Some of them I don't. And when I have incorporated them, sometimes I find that sometimes the old ways still work really well. And so you might say, isn't there a new way to doing that? 2 things. Either I read it and forgot it, or I just didn't want to use it. So, or perhaps I missed it. But anyhow, I'm not perfect at this software by any stretch of the imagination, but I'm here to get you through, and I hope you enjoy it. It's a journey together. If you follow through these, I'm going to tell you, you're going to be at a very high level of design if you go and you do all these exercises and labs and midterm and final. Okay, and you can see the points totals out to 1,000 points because the labs are worth 100 points. The midterms were 300, the finals were 300. That's 1,000 points. So, and the scale is 90 to 100% is an A, 80 to 89 is a B, and so on and so forth. All right, this is just for students at the school. But here we have the introduction to the interface, and I talk about the mouse buttons and such. And for example, looking at this, let's look at this. I'm going to go ahead and hit OK on part, and I invite you to hit OK on part here. And let's look at this. This is the pull down menus strip right there. And I turned it on by tacking that in. If you don't have it, remember, you could get rid of it just by untacking it, and then it disappears. I like to have it in there because I could easily go to Insert, Pattern Mirror, whichever feature, versus saying, okay, now click on this icon. Now, when you have the video, it's nice, but when I'm in class, it's not always as easy. So that's why I like to have that open. This is the ribbon, so these are all the tabs for different things. Now, the features and the sketch tab are the 2 most commonly used tabs that we're going to go through. The sketch tab is like your 2D world. You do have a 3D sketcher. We're not going to use the 3D sketcher until the 7th exercise, so that's like week 9. But you can see that's right here, the 3D sketch. So if you see 3D sketch, don't click on it unless I instruct you to. We're going to use 2D sketches for the most part, and that's really the foundations of the software. And so that sketch tab is for 2-dimensional geometry. We're going to draw profiles, and then we're going to do things with them in 3D, and that's that features tab. That's like the 3D tab. That's going to bring us into extrusions where we can take a profile or revolve a profile, and we're going to learn all about those things here. And then you'll see the SolidWorks add-ins. We are going to use Photoview 360 today. If you don't have it, don't worry. You have to have a premium version of the software in order to get it. Not all students, not all schools actually get the full-blown version. So you might not have it. No worries. You don't really need it. It really makes a nice portfolio, but you could still, I'll show you some other tricks that are really neat for making a nice portfolio without the Photoview 360. But you'll see there's also SolidWorks simulation and some of these other things that you may not have. So just be aware of that. Okay, and that's all for right now. Now going back to the training guide, we talk about mouse buttons. And the mouse buttons here, the left mouse button, I'm just going to say click. When I say click, that means left mouse button. If I want you to right click, that's not as common. And so I'm going to say it probably 2 times. I'll say right click, right click. So just be aware of that. Also, if I'm talking too slow for you, you could go ahead and on YouTube, remember you could double the speed. So just as an FYI, down in the bottom right-hand corner, you could increase the speed or increase by 50% or whatever, and that will get you through this quicker. Those of you who want to just scoot through. Okay, the center mouse button or the center scroll wheel. If it's a wheel, you can depress it, and that's how you rotate. If you scroll it, it zooms in and out. Now the options menu, which is what I call the heart of SolidWorks. I didn't make that up. I heard it years ago, and I really liked it, and it stuck with me. So I call that the heart of SolidWorks. And there's a system options, which we saw earlier, which are global settings. They're going to affect all documents. Some examples of those things are like the screen background color, performance settings, and interface preferences. The document options, those are going to pop up now, and that's where you could adjust the units from metric to inches, the notes, the dimension fonts, the part color for that specific document you're working on. So let's take a look at that. Now the icon is right up here, this little gear. Click on it. We went there earlier, and we saw system options. We're going to bypass system options for a minute. I want to show you document properties. In this class, because it's taking place in the United States, we're using the American National Standard, okay, ANSI. So I would recommend putting it to that. Otherwise, if you're in a different country, by all means, use whatever you have. Like you'll see here, the GO standard. Those of you, my friends in Russia, or the ISO standard, or if you're in Europe or Japan, you could choose whichever is the best option for you. There's just subtle differences, some not so subtle, mostly in drawings that you'll see in the dimensioning. So anyhow, set it to ANSI, go to units, and here you can see IPS, inch pound second. And we're going to keep in that. And then over here, the length. Now, here's the decimal precision. You can see it goes up to 8 decimal place precision. It actually goes higher for the actual models, but we're only getting for our drawings and such. We only want to see up to 8 decimal. We actually only want 3 decimal places, so 0.123. Those of you who are my new students, that's an interesting design perspective, because every decimal place you add of precision costs money. So just be aware of that. When you set things at very high precision, it gets a bit more expensive. The lower precision, if you could design it that way and still have it work and be effective and good quality, you could save money by going with lower precision. But 3 decimal place precision for inches is about as low as you want to go. So anyhow, 0.123. All right, and that's about it here. Hit OK. Now we're going to go ahead and take a look at training guide again. All right, I do give you some notes here, like where do you start a sketch? And you can see we have front, top, and right planes. Now, actually, before we look at the planes, there's the materials. This is the Feature Manager design tree, by the way. I should have made a nice introduction, and I forgot. But the Feature Manager design tree on the left was one of SolidWorks' little inventions. It's my understanding, at least, when I started with them in a bar back in 1997. It was my understanding that that was what they came up with. And really pretty neat how it works. Some people can hide it. Some people don't feel they need it. I like it. But look at this. We have materials. Go ahead and right click. Right click, I say twice. You don't have to double right click. I'm just saying it for reference of speech. I'm going to say it twice. Now you'll see you have all these very basic materials here, or you could click on edit materials. Now, when I say click, I'm usually referring to the left mouse button now. So click, and you'll see this is the materials library that comes with SolidWorks. Now, you could buy additional libraries, especially those of you who might be doing finite element analysis. You might want additional ones. You could customize this one, though, and add your own. You just need the material specifications. For today's part, we're going to go ahead and make it, we could do a plastic, I suppose. Let's go with plastics. Hit the little arrow to the left of plastics. And you'll see there's ABS, there's acrylic, there's Delrin, epoxies, nylons, and so on and so forth. As you click on these, like if I pick Nylon 101, over here on the right, you'll see I have mine set to MPa, which is megapascals, which is more the SI standard based off of metric. And you can see it gives you the yield strength, the tensile strength of the material, Poisson's ratio, the elastic modulus, thermal conductivity, expansion coefficient, and so on. All these values are put in there for you, so if you ever run the analysis on your part and want to test it, it's all there. And just remember, you can modify this too. There's a whole class devoted, it's my CAD 208 class, which is simulation based. And so anyway, let's go ahead and hit apply and then hit close. So now our material is selected. Now it will actually give it the appearance of that material too. So if it's like a acrylic, which by default is clear, we might want to change that later. Anyhow, let's now take a look. Now, where do you start a sketch? Going back to that in the book. Now, the front plane, I always tell my students, when you're just starting off, just go with the front plane. Because if I used to go into great detail into like the theory behind it right away, and I cut the students loose, like, okay, it's lab time, guys, let's go ahead and work on it. And I'd have people there sitting for half an hour trying to figure out what plane. And I'm going to go through that over the next couple weeks through the lessons. But for right now, know that the first 4 parts we're going to do, 4 exercises, are all going to be on the front plane. Midterm we will do on the top plane, and I'll tell you why, and that's when they'll start sinking in as to what plane to select. But honestly, you can pretty much build on any plane as long as you understand where you are in its relation to spatial geometry. But let's go ahead and select the front plane. Now selecting is just one click. Now, you have this toolbar that pops up. You have sketch, and that's what we're going to click on in a second here. But let's just look at some of the other options. There's show. That's to show the plane if you want to turn it on so you could see it. You can see in the screen in the middle there, there's this glowing box. All right. Don't think of those planes as any sort of boundary condition. The last time I heard there was any boundary was, gosh, like almost 20 years ago, that when it was 32-bit and it had a half-mile boundary condition. And that's why this is suited for mechanical, not necessarily architecture. But anyhow, so just know, I don't know if there is any limit now, especially with 64-bit computing. All right, so with that being said, we selected the front plane. Now what I meant to do is, let me click on that again. You have zoom and you have normal to. That's to reorient the screen so it's normal to, or you're parallel to the screen. So let's go ahead and we're going to go to sketch here. Now, if you miss this, notice how mine evaporates as soon as I move my mouse away. If you missed clicking on that, here's what you do. You just go the more scenic route, as I call it. You go to the sketch tab, and I want you to just hit the little arrow underneath sketch. You'll see there's 3 options. There's sketch, 3D sketch, and 3D sketch on plane. Note that 3D sketches, as I said earlier, aren't covered until the 9th week, which is exercise 7. If you want to see how 3D sketches work, go there. It's great for piping, for tubing, for structural steel, things like that. But for general modeling, 3D sketching isn't always the most optimum for what at least the parts we're going to be doing right now. So make sure you just click on sketch, which is a 2-dimensional sketch on the plane. So those planes are essentially your paper. Now you'll see in the center there's an origin, And all three of those planes intersect each other at that origin. That's your zero marker in space. In the lower left, you'll see the Y is vertical, the X is horizontal, and then the Z is coming out at you in this case. All right, you don't have to think too much in that respect as what we call Cartesian coordinates. SolidWorks is, because they call it front, top, and right, it makes things a little bit easier, I think. All right, let's go over here. Now look at this. We have lines, circles, rectangles, and so on. Now, whenever you see an arrow to the right of any geometry, you can hit it, and you'll see there's all the different options. So, for example, today we're just going to look first at corner rectangle. Go ahead and select corner rectangle. Now, move your pointer to the center of the screen. You'll see the pointer is actually turned to a pencil. That means you're sketching. Another couple cues that you're sketching is that when you're starting to sketch, you see the red arrows. If you don't see the red arrows there, then that means you didn't start a sketch. If you see like one arrow, either vertical or horizontal, that means that you didn't orient, you might have selected like the right plane, but you didn't orient yourself to the right plane. You might be oriented to the front. So what I would do is, if that happens to you, and I don't want you to do this unless that's happened, hit this little button. This is the rebuild button. Control B is the fast key. That will get you out of the sketch. And then you could start a new sketch by selecting the plane again and starting to sketch from there, just in the event you make a mistake. Note that if there's any geometry that's in that sketch, it might have difficulty removing it. It'll actually, it's not difficult, it's just that you might see gray geometry floating around. You could hide it, you could delete it, whatever you want to do. Okay, anyhow, move your pointer to the origin. Now you'll see when you get over the origin with your pointer, when you get the orange dot that appears, you'll also see a little symbol to the right of your pointer, a little yellow box, and it has a symbol in it. And those symbols mean something, like in this case, it means coincident. There's two types of constraints inside SolidWorks, and this is in the training guide. And essentially you have dimensional constraints. So you could dimension the height or length or width or angle or diameter. And then you have constraints, which are geometric constraints, parallelism, perpendicularity, coincident, tangency, those types of things. Those extra levels of constraints, or extra constraints as I'll call them, enable you to sketch things much easier than you could have back in an old CAD system of the 80s. Because we have this functionality now, you don't have to do all of what I used to call the witchcraft of like trying out how to get things tangent and all these little tricks. SolidWorks has always had this built in, so it never had the issues. But older CAD systems, and if you've come over or migrated from an older CAD system, you might know what I mean, especially the 2D CAD systems. All right, now let's go ahead and click one time. Now release the mouse button and drag it to the upper right. You'll see an X and a Y. Like mine is just an arbitrary 1.859, and the Y is 3.144. Get it to any dimension like that. That's pretty good. And you're just going to click. Now our box is going to eventually be 3 by 5 high. And you'll see here we have our box constructed. Now I'm going to show you the don't right now. There's going to be do's and there's going to be don'ts. And this one, especially as a new user, if you ever are trying to get a job, and if someone sees you, a manager who's testing you, do this, they'll probably ask you to leave. You won't be hired. And this is down here in the lower left, you have the parameters. Now an advanced user can use this and understand that it's not actually constraining. It's just giving dimensions, that plugin. And so don't use these down here. See these? You could, like here, the Y, let's say I type in 5, hit enter, you'll see it will expand it. But don't rely on those, because this is why. I'm going to hit escape on my keyboard. Now I'm going to hit the F key. The F key on your keyboard is zoom to fit. Go ahead and try it, F on your keyboard for fit. Okay, now I hit escape. You could hit escape too. Take your pointer and see these little lines. You could actually, or lines are actually the corners. Click on it and drag. And now look at that. It just moved on its own. Well, not on its own, you dragged it, but there was no specific. Like here we could see actually how far we moved it, but just be careful of that. I've been working in places, design firms, where it was a fireable offense if you didn't constrain it the way I'm about to show you. So don't use that, especially those of you in my class. If you're working at a company and that's the way they do it, do what they tell you to. But in my classes, I want to teach you the way so you don't get fired. In fact, that you look very well trained on this. So I want you to hit the little arrow underneath Smart Dimensions. Now you'll see there's Smart Dimensions, horizontal, vertical, baseline, chain, horizontal ordinate, dimensional ordinate, vertical, bunch of them. We're looking just for Smart Dimension right now. Now take your pointer, and a lot of new users have a tendency, like, they want to dimension this line, and so they click on the ends and they get a dimension. That's 1 and 2 clicks, and then a third to drop the dimension. So that's 3 clicks. I like, especially when lines are, you want to dimension parallel to a line, just click on the line. Save that extra click and moving the mouse across the screen. So hover over this line anywhere, but not on a point. Notice a midpoint does appear. You could select it, but I don't want you to do that. We don't want a midpoint dimension there. So click on the line and release it. Now you'll see there's actually a dimension there. Now those of you in my class that are new to dimensioning, here's the thing. Try and center the dimensions. Remember, the goal of dimensioning is to lay them out so they're easy to interpret and read. If you dimension, like, and leave the dimension right there, when you print it out, if you print it out, it might not be able to interpret what that number is on there. So just be aware. Try and center it. Kind of think of it like you're playing soccer or football. You have the goal and you want to get in between the lines of the goal. So we have here the extension lines. Center it and click. And those of you in my class, I want you to do it this way. I want your drawings to look professional. If you have them scattered all over and they look like garbage, not only does it look bad, especially if you use this for a portfolio piece, it's going to look terrible. But it's just laying them out this way later on will have its benefits if you have to create a drawing, because those dimensions will appear in the drawing. You can call them up or retrieve them and they'll show exactly as they are there. So another reason, there's 2 good reasons to have nice laid out dimensions. So go ahead and type in 5 here. Now here's another thing. Those of you who might be tested one day at a company, they'll sit down with you and they want to watch you. Usually they'll sit, like, this is what happened to me a couple times when I took jobs. They sit behind you and they're like, okay, here's a drawing, go ahead and make this part. Now I was a manager, and this is why I'm giving you these tidbits, because this is what I looked out for hiring people. If I saw someone go ahead with SolidWorks, add them in this modify box. Now, right now, everything is blue for the numbers. Right now, you could go ahead and type in 5, and not 5.000, just 5. SolidWorks will add the decimal place, and the precision, it'll just make it 0, unless it's more complex than that, of course, you have to put it in. But where I have students that really look amateur, if they're going on an interview, is this. They click at the end here, and then they backspace. Never do that on a job interview. It looks like you don't know what you're doing. So don't, I'm just giving you that advice. If you don't care, if you're just taking this class for fun, I don't really mind. I'm just showing you the best practices so you look exceptional at this. All right, now you could type in 5. But if I see this 5.00, sometimes I see people type that in. It's kind of an eye roll. All right, so if it's just 5 inches, just leave it at 5. If it's 5.125, of course, plug that in. All right, I'm just going to leave it at 5, and you can hit Enter or the green check mark. Another thing, try using your number keyboard on the right, so make sure number lock is on, that little keypad. Again, that looks very professional. That means if someone's, versus using the numbers at the top. If you have a keyboard that has that to the right, definitely use it. Laptops don't always have it, so you have to use the numbers at the top, is what it is. Go ahead and hit the green check. Now it actually constrained that for the height. If we were to try and grab that top, which we can't right now because we actually have the dimension to allow, we'd have to hit escape, it wouldn't move. So it's locked down. That's what you want to do. You want to add dimensions like this. Now let's go ahead and try that again. Click on this bottom line here. Stay away from the points. Drag it down, center it. Now if you need more space, remember, you can hit F on your keyboard. It'll zoom to fit. Center that between the goalposts, click. Now, don't backspace on this. I want you all to try it this way. Just type 3. And look at that, it enters it. Hit enter on your keyboard. It's constrained. And notice, you might not have noticed, these lines were blue. They've turned black. That means it's fully defined. It has the constraints that were necessary to fully define it. You want your sketches fully defined. You can see right down here it says fully defined on the lower right corner here. Okay, you want your sketches to be fully defined by the time they go into production. If they're underdefined, that means you're missing dimensions. Or you might use that technique that I showed you, the don't technique. So just be aware of that. Now you might see these little green squares. Try clicking on this green one up here at the top. After you hit escape first, hit escape on your keyboard before you do this. Click on it, it should turn blue. And then on your keyboard, hit the delete key. Now, notice the line turned blue. Watch what it can do now. If I grab a corner, it could go at an angle. Now, you might want that, but not in this exercise. So what we can do, rather than reestablish it, we could reestablish it. You could just click on that line. And right here, on the quick launch, there's actually a make horizontal option. You could click on that. Go ahead if you want. Otherwise, I'll show you another thing you could do. There's also the undo button up here. Right here you have undo, or it's Control Z like it is in most programs. Hit that. And then you can hit it a second time and it brings back that constraint. So these are that second layer of constraints. Remember, we have dimensions and then you have these relations. So those are the two that you want to use. So these are defining it to be horizontal in this case. And that's why you see the little horizontal line there. See the vertical one here. This is coincidence. So it's adding those automatically as we do it. We could manually take over and add them too if we need to, just by clicking on them like you saw me do. Like right here, you'll see it brings those up. It doesn't bring up a whole array. SolidWorks employs what's called the object action paradigm. And this is based off database technology that, my understanding, what I read, NASA developed it years ago. And what that does is it ensures that it only gives you options that you could use for the entity selected. So it limits giving you a whole bunch or a whole array of tools that you can't even use. So it's just meant to make things easier. It's like if you're building a house and you needed to hammer in some nails, it's only going to give you a hammer instead of giving you a screwdriver and all these other tools that you might not need. So that's really a nice feature. Most softwares employ that these days, but that was kind of a neat thing about SolidWorks when I first started with it. Okay, we're ready to go in 3D. If you want, hit your F key again just to zoom to fit. And now let's go to the Features tab. Now the Features tab brings you into the 3D world. And we're going to do Extruded Boss Base. So go ahead and click on Extruded Boss Base. And you'll see over here on the left, the feature tree is transformed. Feature tree is still back there by clicking on this tab, but then it pops out here now because when you're in an extrusion feature or any sort of feature, it gives you the information right here that you could adjust and change. So the from, that's more advanced. We're not going to go into that right now. It is very good, but just note the next 4 weeks we're not going to use it. We're always going to go off of a plane. In the advanced class, we'll see how that works. But here we have direction. Now we have the condition is blind. It's in just one direction. This will flip it reverse. A lot of times you'll see a reverse button. Other CAD systems out there sometimes give you a negative option, like you put a negative in front of a number and it will do that. SolidWorks doesn't employ that technique very often. Every once in a while it's in there. Not consistent though, so just be aware. It usually has a flip switch like this. All right, and here we can see the depth. So we could actually type in a value. You could type in 0.5 right there, hit enter one time, and you can see it just it's giving us a preview here of this like jello part. It's transparent. Now you could also use the little arrow in the center. When the arrow turns orange, or I should say the outside profile turns orange, that means you're on the arrow. Oh, there we go. Click on the arrow. You can drag it. You get this little ruler, and it's pretty nice. Sometimes it's a little bit of a challenge if you have something very specific you're trying to hone in on, but you'll see you can actually reverse it as well. but I'm going to go ahead and type in 0.5 again, just to lock it in, and hit the green check mark in the upper left corner. Now you'll see a little blue preview. To get rid of that, you can either click somewhere on the screen or just hit escape on your keyboard. It's just the visuals left behind. Now we're going to take a look at how to rotate, orient, pan, all those fun things right now. So first of all, before you do anything, hit your arrow keys on your keyboard, left and right, up and down. You'll see it rotates in 15-degree increments using the arrow keys. Hold Control and hit your arrow keys, and that's pan. Hold Alt and your arrow keys, and that's clockwise or counterclockwise rotation. Shift and your arrow keys rotates in 90-degree increments. Z is to zoom out. Shift Z is to zoom in. Do not Control Z. That's undo. There is a redo up here. Just be aware. Once it, you could go to Edit and Redo in the event you hit undo. All right. Now hit your space bar. No more. Hit your space bar, and you might see this little, what I call the ice cube. It's a really cool tool. At first, I wasn't sure if I liked it or not, but over the years, I've really come to like it. You'll see you could click on these polygons, like here, this corner polygon will give us isometric. Hit the space bar again. Notice the orientation bar here. Now, this has been in SolidWorks for years, and seasoned users pin it in and just keep it, especially if you have a lot of real estate on your screen. You can pin it and keep it in the corner if you like. I prefer just to get rid of it. It's too much on the screen for me, but it is kind of neat. Look at this. You could, I'm going to pin it in just temporarily. And you can go to front, right, left, top, back. Here's the isometric, dimetric, trimetric. All right, and normal 2, you have to select a face and then click on normal 2 and it'll bring you to that. So that's any selected face. It's really useful for unusual angles that you might come across on models that you draw. Okay, I'm going to go back to front. Now this allows you to put in additional views and split the screen up. All right, those of you who like some other CAD systems, or like this is very popular for people with digital content creation who've used Blender or Rhino or even 3D Studio Max. But let's go ahead and click on single view here. And then these we're going to get into. These are for creating new views and saving views and things like that. It's really neat stuff. All right, so I'm going to stick with front. I'm going to go ahead and close that. Oh, let me hit again. Remember, spacebar brings that up. This turns off that view selector, which I call is the ice cube, because it looks kind of like an ice cube to me. All right, so that brings that up, keeps it up. And I'm going to get rid of this. Okay, now here's how to rotate without any of that, with just your mouse button. So on your mouse, if you have a wheel, the wheel zooms in and out. Okay. Now, depending upon where you put your pointer, you could zoom up. Watch this. I'm going to move my pointer to this bottom right corner. Try it. Stay and hover over that pointer no matter how far or how close you zoom up to it. And it will allow you to zoom to that region. Okay, so get used to that. A lot of people don't realize the functionality that you have there. You could focus in. It's like a focal point in an area. Okay. F on your keyboard again, zoom to fit. Now to rotate, that wheel is actually a button. If you push it down and hold it, don't scroll it, sorry, I scrolled it. Push it, did you hear it click? And then you could hold it and rotate. Move your mouse left, right, up and down with that depressed. And you've got it. I would recommend, if you want, pause the video, pause it for about a couple minutes and play with those things. Remember the arrow keys, the space bar. Now be aware there are more functions up here. Here's zoom to fit. Remember the F in parentheses. Here's zoom to area. This one is previous view. This one is section view. This is really cool. You can actually pivot and rotate your sections. by grabbing these little things here. Just be careful if you hit enter, it stays that way, so you have to click on that section view again to turn it off. Here you have dynamic, we're not going to get into that right now. You have view orientation, which brings us back to that little box, so that's up here too, all the same options. And notice the fast keys. Those of you who like fast keys, I'll tell you what, if you're going to apply for a job, practice those fast keys. Nothing more impresses a manager when someone is cranking away at fast keys, because it shows a level of detail and knowledge that you've attained of the software. When I saw people that I would hire, when I used to hire people for SolidWorks, I saw them using fast keys and they remember them. It's like, wow, that's impressive. So it's a good thing to know. All right. Also, you have display style. Hit this little arrow here and shaded. And what I was getting at, let me pause for a second. You could pause and rotate and try all those different view orientations out. That's all I was saying. It's good to get or familiarize yourself with it. There's even more functions than that, like the right mouse button. If you hold that, move it left, right, up, and down. It gives you orientations as well, but it's just too much. It's overload by that time. But there's a lot of functions, and there's even a monocle to zoom up on things. But anyway, shaded with edges, shaded takes away the edges. I like shaded with edges. There's also hidden lines removed. You have hidden lines visible. Wireframe, good old wireframe from the 1980s. And then right here you have integrated preview, which only is available if you have Photoview 360 on your computer. And remember, some of you might not have that. Okay, moving along here. Let's go back to shaded with edges. Oh, there's also these hide show items. We're not going to go into that just yet. But here, this brings up the color palettes, so you could adjust colors. I don't want to do that just yet. I actually was hoping to click on this. I wanted to bypass that one. But you'll see here that you can change it to plain white, brighten it, a dark background, rooftop. There's a lot of them. My favorite when I'm up on the big screen for presentation purposes is this one right here, the plain white. But the 3-point faded is very nice too. But you pick one that you like. Okay, and then here we have these options. There's cartoon. Okay, it wants to use the Photoview 360. I'm not going to turn that on just a second. There's perspective, and that gives you a vanishing point. Okay, note about perspective. When you click on it, the dimensions might be a little difficult to see. Like, look at this. If you double click on it with perspective, they're really tiny in some cases, or if you're really close, they get really big. I guess it's not too bad. They've actually made some improvements with that over the years. So, but still, it's a little difficult to read sometimes, especially if you have a cluster of dimensions. Oh, by the way, to bring up those dimensions, just double click on the surface of the model. Now, let's go over here. There's ambient occlusion. There's shadows and shade mode. See the little shadow that appears there. And I usually turn those off. They're a little bit intensive sometimes. Like if you have a tablet you're using SolidWorks on that isn't very powerful. If you don't have a good graphics card, those might be a little intensive on the system, might be a little slow. But the view settings, you'll see real view graphics. And this is where I was saying earlier with the hardware, you want a professional graphics card. And NVIDIA, basically the Radeon Pro, the Fire Pro from AMD, those are good cards. NVIDIA has the Quadro series. Quadro series are exceptional as well. And Intel has their built-in with certain Xeon processors, actually has real view graphics built into it. Now, there is supposedly, and I know it's out there, there's actually a hack. Those of you who have gaming cards that don't support this, because this is only supported on professional cards. There is a hack. You could look it up. I think there's some YouTube videos on how to do it. I don't recommend doing it, because anytime you do it, you get some weird results. You could really chew up your system. So unless you really want to try it, but don't use it at your own risk is all I'm saying. It's a registry hack. Okay, so anyhow, so there we have it. I'm going to turn off perspective, and I'm going to turn off cartoon. Okay, back to spacebar, isometric. Now we're going to go ahead and continue building this and finish it off. Select this face. Now, the last time we selected a plane to sketch on, note that you could select on any flat surface of the model. Doesn't matter what angle it's at. You can sketch on it as long as it's flat. If it's curved, you have to use a 3D sketcher maybe for that. But let's go ahead and click on it. Now, you'll see that there is this toolbar that appears, the quick launch. There's a lot of options on here. What we're looking for is this sketch one. Now there's a edit sketch above it. Be careful not to select edit sketch. This edit sketch will actually edit that 5x3 square or rectangle that we drew. And you don't want to go back and edit that. So be careful. You want this button right here. Or go back up here, sketch, and sketch. And it should start a sketch now on that surface, which remember is a 1/2 inch offset from the plane we sketched on, which is still there. Okay, now that we're sketching, go back to the corner rectangle. Orient yourself right in the lower left corner. Now here we're sketching in isometric. And I have some students who I think are more based on 2D thinking and they get nervous sketching in isometric. It's really not that bad. I would recommend trying it. If you don't like it, remember you could always select the space bar and go to the front view orientation if this is bothering you, and eventually you'll pick it up. But anyway, click on this origin. Make sure you get the orange dot. Drag your pointer over to this edge, and SolidWorks will highlight the right edge orange, not the very far right, but the one that's closest on the surface here, just like mine. You'll see X is about 3 inches, and Y is like some arbitrary number, 1.89 in my case. We actually want it to be 1.5, so don't worry about that. Just get it close to 1.5. Click. Now go to Smart Dimension. Remember, use Smart Dimension. Click on this right side, drag the dimension to the right, make sure you center it, just like the goalpost. You want to kick right in the middle. And go ahead and set that to 1.5. Hit Enter. Now you could go to the Features tab up here and go to Extrude Boss Base. We're going to keep it at 0.5, and SolidWorks maintains in its memory the 0.5 from last time, so we're in good shape. We didn't even have to type in a number. Another thing that pops up here, merge results. We didn't see that last time because there was nothing to merge with. Merge results, you want to keep that on in this case. It is very useful for multi-body parts, which SolidWorks enables you to do. This is not a multi-body part, this is one body. So like for mold making, it's very useful to turn off merge results when you're making like multiple halves of a mold or something. But in this case, make sure you leave it on. In most cases, almost all my exercises, unless you're in the advanced class, you're never going to turn off merge results. Go ahead and hit the green check. Click somewhere on the screen, and look at that. Now we're going to go ahead and pierce a hole in here. Now select this face right here and go to Sketch again. Now select your circle tool and hover right about here in this upper left region. Click and drag out a circle. Now the radius is popping up about 3-ish, 0.3-ish is good. Now go to Smart Dimension, click on the arrow. I should say click on the outside of the circle, not the center point. I have students click on the center point. This is the center point. You don't want the center point just yet. That's for positioning. You want the outside. Drag this out in the upper left and click, and let's make that 0.75, so 3/4 of an inch diameter. Now, mind you, there is a hole feature that I mentioned. It's a hole wizard. We're not going to use that till the 4th week, or exercise 4. So if you want, you can fast forward and see how that works. It's really cool. But I'm showing you how to chisel away using Extrude Cut. In this case, a hole. Very simple hole. Okay, now we want to position this, and we can position from the center point. Now you could select the actual outside of the circle to do this too, but let's go ahead and select the center point. And if you were measuring this out, you would measure it from like the left edge of the part to this part, just like how you would measure anything. Like if you're putting a nail to hang a picture up, you want to measure them accordingly. So click on that center point one time, click on this vertical line on the left. Now move your pointer straight up and again, center this dimension. Click, make that 1 inch. Now, select the center point again. Now be careful, there's 2 points. There's a light blue square. That's the end point of the actual extension line. You don't want that. you want the dark blue cross, or its a little plus symbol in the middle. That's the center point we're positioning to. So click on that, and then select the bottom edge. You know what, let's click on the top edge. Click on the top edge here. Stay away from the points. Drag it to the left out here, center it, and make that 1 inch. Type in 1. Now, if you'd like, hit your space bar and click on the front of the ice cube, or click over here to front, or Control 1 is the fast key for front. You could lay these dimensions out so that they look nice, because remember what I was saying earlier, when you make drawings for this, it'll show up exactly like this. So if it doesn't look quite like that, might not look too good. All right, now we could go to features. This is where SolidWorks is unique. SolidWorks actually has an extruded cut feature separate. Other CAD systems typically, and SolidWorks, similar CAD systems, give you extrude and then you could cut or you could add material. This actually has a separate icon, so just remember that, extrude cut. Now I'm going to rotate with my middle wheel. Hold the wheel down like it's a button, don't scroll it, and rotate, move your mouse to the left a little bit so you can see it's piercing through, or at least it looks like it. You see that yellow ring in the back. Now, we've been going blind the last 2 times for our depth, which is just one direction. You could go to direction 2 or mid-plane as well. We don't want that. But there are other options here. Hit the little arrow to the right of blind, and you'll see there's through all, both sides. If there's something on the other side to cut, select that. There's not in this case. Up the vertex, surface. There's a bunch of neat little tools here. We want through all, and here's why. There's something called design intent. Design intent is a practiced type of deal where students or people who use SolidWorks have obtained this, like, just knowledge of do's and don'ts, or best practices, as I call them. Essentially, this is a plan on how you want it to behave if a change comes down, and change always occurs in design, almost always. No one ever makes one part and it's ready. I mean, it's very rare. So you want to have it to where it's easy to update. So we made this wall here a 1/2 inch thick, and we're piercing a hole through it that we know is going to always go through all. And right now it's set to 0.5, but we wanted to set it through all because in the event that we ever thicken that from a 1/2 inch, let's say, you know, it wasn't strong enough, that this plate needs to be 3/4 of an inch. If you make it 3/4 of an inch, you're gonna have to go back and you're gonna have to change the hole depth too every time. But through all will ensure it always goes through. So that's just a little teaser of what design intent is. And again, that's one of those things, I plant the seed, I tell you a little bit about it, but I don't want you to think about it too much early on. Just rip through these models, try and model them whatever way you think your mind is going to work. It's kind of like Tetris, like figuring out the best methods, you know, and best strategies. But you'll learn those in time. It's not just, you can't think about it right away. All right, so through all, hit the green check and click. All right, now we're going to do some additional features here. Let's go to the Fillet tool. If you want, hit your space bar, go back to isometric right here, or Control 7 on your keyboard. Go to the Fillet tool, fillet right up here, and you'll see there's different types of fillets. There's a Fillet Expert, there's manual. I like going with manual. Fillet Expert is a very nice tool. We'll maybe talk about that in a later date. But items to fillet, first of all, make sure you turn on full preview here. Full preview, check that little button. And right here you see it's set to 0.1. That's the default when you're going with inches. Go ahead and select this edge. Now, imagine you're filing something down. Here's your file. You're going to hit it on the edge. You wouldn't hit it from the sides, which I have a lot of, the reason why I say this is because I have a lot of students who learned 2D CAD before they did 3D, and they hit the wrong edges. So it's the edge that you would hit. So click on this edge. And full preview gives you that yellow preview that you see there. Now, go back over here to the left. You could plug in the numbers there on the right, or over here, you can plug them in, or you could just bump this little arrow up and keep bumping it up till 1 inch appears. Okay? Go ahead and select this edge right down here. Now, be careful. You could accidentally select a face, and a face might error out. If you see the previews disappear, that's usually means it's a sure sign it's probably aired out. It can't put that fillet in. Just due to the conditions, it's just not enough room usually. Okay, so you could click on a surface and click on it again. It's just like a light switch. Click once on it, it selects it. Click a second time, it deselects it. All right, make sure you get this edge here. Wait for the highlight, click on that edge, and that's what it should look like. Hit the green check. Don't put a lot more on here. You could do it later, but for right now, I want you to do it this way. Okay, so now we have those like that. Now let's go, I want you to find the chamfer tool. The chamfer tool is buried underneath the fillet tool. So hit the little arrow underneath fillet and go to chamfer. Now fillets are a nice radius. You'll hear some people call them blends, radiuses, rounds, but a chamfer is actually an angle. Okay, so over here we have 90-degree angles we're going to put them on. So if we make them equal or at 45 degrees, it's going to be equal. So here we'll leave it at 45 degrees and put in 0.125 though for the actual distance. See the D is equal to 40 and 45 degrees for the angle. Make sure full preview is turned on. Also tangent propagation, don't turn that off. That's really nice to have on. It propagates along radiuses, or the fillets I should say. So go ahead and select this edge up here and you'll see it will chamfer and preview that. And click on this edge here and hit the green check. And look at that. We've turned a very ordinary part into something that looks a bit more designer. Let's now rotate this around. Now take a break if you can't get it rotated in the same way I have it here. But now get it rotated there. If you want, pause and get it looking just like mine with your middle mouse button or the arrow keys, whatever you prefer. Now let's go to the shell command up here. Now be really careful here. Don't just enter, don't hit the green check mark. We want it to be at 0.1 for the wall thickness. But select this face first, select this side, bottom face, and then this side face. Just those three. Those are faces we're going to open up, and everything else is going to be shelled around it. Go ahead and hit the green check mark. If you hit enter too early and then you try it again, it will fail. So you might have to go over here and edit that shell by right-clicking. Remember, right-click, and it enables you to edit that feature and takes you back. So if you want, you could turn off a face. Or look at this, I could add this one right here. Hit the green check. So right-clicking on these enables you to alter or change them. See all the options. If you hit the little arrows, you'll see the sketches. You could edit those sketches. You could hide them. You could show them. All sorts of fun things that you could do in here. Okay, finally with the photo rendering, let's take a look at that. Let's now switch this to perspective. And we're going to go ahead. My perspective, by the way, is customized. I'll show you how to customize it later. It's maybe a little bit more dramatic than yours. But let's go to render tools. Now, if you don't have render tools, go to SolidWorks add-ins and turn on Photoview 360. You may not have this. And if you don't have it, you can just watch. Okay. Anyway, go to render tools and rotate this the way you'd want to get it. Go to select this face of this chamfer and go here to this appearance and hit the little arrow. Move down and find part 2 here and click on that little sphere. And the whole part will be affected by this. Now you could just change the color, or you can actually change the material type. Like, let's say I wanted to go with white high gloss plastic. Hit the green check. Now click on that fillet again, hit the little arrow. Now there's a trumping order here. If I just click on the face, that one highlighted blue face will change. But if I click on the chamfer, all the chamfers will change. So over here now, it will just change these. So we could go over here, instead of plastic, hit the little arrow. I'm going to go with painted. I'm going to go to car. I'm just showing you some fun stuff. I'm going to go with gloss blue, hit the green check. And now you could hit also, if you go to the edit scene. Now here, there's lots of neat things. Go to the XY and it changes this a little bit. Hit the green check. Turn on your perspective again, because vanishing point gives you a more realistic appearance, and hit integrated preview. Now this is where a faster processor is going to do it a lot quicker than a slower processor. The more cores you have, the faster this will operate. So if I hit Control-Alt-Delete and bring up my task manager, you can actually see it's multi-threaded, and it's already done on mine. But if you go to Open Resource Manager, and oops, don't want to maximize that. And we can see the CPU usage. Right now, they're not being used. There's 32 cores here. But if I rotate, and let's bring that back, you can see they all bump up. And see how it gets better looking? Again, the more cores you have, the faster it will do this. And this is a very high-end system. So note that's why it's rendering so quickly. Yours, unless you have this system, may not be rendering. Especially laptops don't run. They probably run at best half the speed, if not 1/3 the speed. Okay, so there we have some methods there, and I want to now show you how to do the labs. So if you want, I would recommend pausing and trying the labs. The labs are in the book. And if you see here, if you scroll down, exercise 1, lab 1 starts on page 25. And lab 1B is on page 26. And here are the drawings for those two parts. And patterns and arrays and mirroring will be covered in future versions. I'll actually show you a little bit of patterning just for the heck of it, but the next couple of weeks we're going to cover those in more detail. So I usually recommend you don't do those just yet. Okay, so in working with this, when you go there to the Vertani1.com and you go to that link, you could get to the manual. And you might want to rotate these. And the way you could rotate them is if you just download it. So hit download. And down at the bottom left, once it's downloaded, click on it. And it brings it up. And you get to that page 23, 25. And watch this, you could actually click on it, and here's rotate. And just hit it 3 times, and it should rotate sideways here. And if you have dual screens, drag it over to the second screen, and you could continue working on it. So as we see here, I'm going to go through these rather quickly, and I don't always put all the dimensions in, but I do expect my students to put all the dimensions in. This is just to show you maybe some best techniques or quick techniques to doing this. So we see that it's 2 by 3.5. Then we have, it looks like an F on its side, basically. We have, this is 1 inch, then 1.75, then 2.5. And the 3.5 defines the very tail end, so you don't have to add that again on top. So what they call this is like a baseline dimension over here. And then over here we have 0.85 by 1. And then again, the 2 inches, we don't have to define that. But it's just extruded a 1/2 inch thick. So let's give that a go. Go to New, Part, and hit OK. You could double click on Part or hit Enter. Select the front plane, start a sketch, and use the line tool. Now, I know we didn't use the line tool last time, so let's try. Click on Line, click on the origin, make sure you get the orange dot. Click once, release it, drag it up 2 inches, and this is where it's very helpful to get close to the marker. So see, I have 2.07, close enough. Once we add the dimensions, it'll fully constrain it exactly how we want it. So click, drag it to the right. Now take a look at the, to the right of your pointer. Always make sure that you're, in this case, like if you want horizontal or vertical, that you get the symbols to the right. See, we have the horizontal symbol to the right of the pointer, and we also see the horizontal line. Follow that. Bring that up about 1 inch. Click, drag it down, and this one goes about roughly half the depth. So see it in first to the midpoint. That's close enough. Click, drag this across. This one only goes about 0.75-ish. Click, drag it up. You're going to infer to that top line. Now, sadly, it doesn't automatically capture this relationship. So we're going to have to go back and fix that one later. We can either do it with the dimension, or I'm going to show you a trick on how to add a relation that will align it to the other one. We'll make it collinear. So click here, drag this across, this one about 1 inch or so. Click, drag this down. Now this goes down a little bit further than the halfway point. Click, drag this across about 0.8, 0.9-ish, maybe 1 inch is fine. Drag this down, and you should be able to infer to the origin again. When you get the inference line, see that horizontal dashed line? Click, and connect it. Click. Now we could go to the Smart Dimension tool. Dimension this line first. I mean, it really doesn't matter which line you dimension in this case, the horizontal or vertical. I'm going to go to the horizontal now, and this is 3.5. And let's bring up our drawing just to verify. So you see 2 and 3.5, then 1, 1.75, 2.5. So right here, 1. Again, center of the dimension. And notice we've gone back to 2 decimal places, and that's okay. Remember, you could go to the tools options up here and the document properties, units, and specify 3 decimal places. You don't really need it here. So let's go ahead and dimension from here to here now and stagger the dimension, 1.75. And then this last from here to here will be 2.5. Now click on this dimension here, 0.875, I believe. Let's double check. Oh, it's actually 0.85. Okay, and then from this line to the bottom line will be 1 inch. And it was really there because it snapped to it, but it wasn't complete. Now this needs to be aligned. See, this line is still blue. It's not fully defined. So hit escape on your keyboard, and here's what we could do. We could manually add the relationship. The way you do this, select the blue line, release it. Now hold your control key down after you release your mouse button. Don't hold the mouse button because it'll make a copy if you do this. Okay, so all I'm holding is just the control key. Now select this line, release the control, release the mouse, and take a look on the left-hand side. You'll see add relations, and now we see a much larger array of options to choose from. Horizontal, vertical, and look at there, there's collinear. Collinear will align them. So click on collinear, hit the green check, and look at that, we no longer needed to add another dimension. You could, but for our drawing, we don't really need it. But you see it put in the little dashed line there to indicate that it's aligned. And we can see all these little symbols that are there too. Now, I'm going to hit the F key. Now, at this point, you're becoming, you're getting past the first day. And these little green boxes might become a little unnecessary. And this is how you could shut them off and never have them turn on again on that workstation you're using. Just go to View, because it's something you see. Go to Hide Show, and you're looking for Sketch Relations. And it's the 4th one to the bottom. Turn it off, and then click over here, and they're all gone. They're still there. Now watch this. If you click on a line, the relations come up. So it's not like they're gone. They're just hiding, because you don't need to see them all the time. Sometimes, especially when people are learning the software, it's nice to have them out there so you grasp an understanding of what they're used for. But now we're ready to extrude. So you remember where we go here? One of these tabs to go into the 3D world. It's not Sketch. Sketch is 2D. Features. Go to Extrude Boss Base. Set this to 0.5 and hit the green check. Click somewhere. Now, I'm going to zoom up here. Now, you could just leave it like this, but those of you who are trying to make a portfolio, my students, I very much encourage you to make a portfolio, because this portfolio will be very instrumental in getting you a job. Dress these up a bit. Have fun with it. Experiment with it. You're going to learn more than I'm going to teach you, actually, just by tinkering. So I encourage you to enhance this. And what I mean by that, try going to the Fillet tool here. Put some fillets in on these corners. See what it does. Look at this. You could use X-ray vision, Superman X-ray vision, and click on that corner there. Here. Click there, and there, and there. Now we'll even get the bottom ones. And again, Superman X-ray vision, we could see this bottom in the corner. And if you want to get all the edges, click on the face. I'm letting you know that one a little bit in advance. We usually don't talk about this until the 3rd week. So click on the face and look at that. It adds fillets all the way around that entire face. You don't always want that, but in this case it works. Remember, if you don't want it, click on that face again, it turns it off. But go ahead and you could turn that on. Or maybe you might want to push chamfer. You know what? I'm going to leave it. And I'm going to increase the fillet over here and hit the green check. Now I'm going to go to the chamfer tool. Chamfer was underneath fillet. And we'll keep it at 0.125 and select the whole face. Look at that. All right, now rotate and let's shell it out. Go to the shell command, select this face here, and hit the green check. Now notice to the right of my pointer I have a little green check, indicating the right mouse button will do the same thing as applying it with the green check mark or enter. Go ahead and use that. And there you go. Again, we took a very ordinary part, made it slightly more interesting, a better portfolio piece. And if you like, you could even change the colors. Click on the chamfer. Remember what we did before? You could go over here. If you want just the whole chamfer changed colors, click on it. And I'm going to go to metals this time. I'm going to go to brass and polished brass. Hit the green check. Now I'm going to click on this face. I'm going to just change this one face right here. And I'm going to make that, let's see, chrome and polished chrome. And then the rest of the part, I'm going to click here, click on this little arrow to the right of the beach ball, and the whole part, remember all those above it will trump it, so they will override those. So click on this ball here, and I'm going to go with plastics, and I'm going to go with actually clear plastic. You know what, actually, let's see here. Yeah, clear plastic and polypropylene or polycarbonate. Let's go polycarbonate. Hit the green check. All right, now if we flip it, it might look not that good, but we could go ahead and turn on perspective and then go to render tools and integrated preview. Now you have the ability to final render, and that will output a file like a JPEG or PNG or whatever you specify. There's several that you can choose from. And there we go with our rendering there. The longer you let it sit, the better it's going to look. All right. At this point, if you want to make a portfolio or start making a portfolio, like here, I actually have a LibreOffice, an Office Writer, and I'll show you how to use this. And Microsoft Word does the same. So here I have it. I'm going to put down, this is L1, and then there is insert, and you could do image from file usually, or but this is what I do. I want this photorealistic rendering, so I'm going to hold Alt on my keyboard, and that's because I have dual monitors, and print screen on my keyboard in the upper right. So hold Alt, hit print screen one time. It's in the upper right of your keyboard. Release Alt. Now we could go to Libre Writer, and underneath there, Control V as in Victor, and it pastes it in there. Now what you can do is, let's maximize this, and you have the ability to crop it and have, like right here is crop, and you could crop this down, get rid of the extra window space, click off of it, drag it there, stretch it out, and you've got a beautiful image for your portfolio. And what you could do, you could type in here, you know, or you could, let's say you want L1, you could put down some of the things that you've done on it. So for example, it's extrusion, and oops, and you can put whatever you like. So anyhow, then underneath it, you can put the next image for L1B and so on and so forth. And then you have this beautiful portfolio, and you could dress it up so much more than this. This is just showing you the bare basics. Okay, so I'm going to turn off integrated preview. It's a good idea to turn off because every time you rotate, it's going to suck up system resources while it renders. So turn it off when you're done. Those of you who don't have that, you could actually use this image. Yours is going to look more like this, though. Without real view, it looks like that. But still, decent looking image you can use for your portfolios. Sometimes also to put the dimensions in is a nice thing, like double click, and that way they know it's a CAD model. All right. And again, you would just do Alt Print Screen, drop that into your Microsoft Office or LibreOffice, whatever you're using. Let's do the next model. Let's go back here. The next model is this box, and it's a 3x5, so it's very same size as the exercise one. Remember, if you ever get stuck on these, you could go to the original exercise, because basically everything that you do in the exercise is in these lessons, with the exception sometimes in the future you're going to have just reviews on certain things that weren't covered. But anyhow, everything is covered. It just might be was in a different week. So let's do that. 3x5, and it's 1.5 thick. So go to File, New, Part, just double click, Front Plane. Actually, I'm going to do it on the top plane just to show you. If you want to do it on the top plane, that's fine. Start a sketch. And this time, I'm going to show you a different tool. Instead of the corner rectangle, try using center rectangle. We haven't used this yet. Center rectangle. You locate the center at the origin, click and drag it out, smart dimension it, 5 inches wide by 3 inches in height. Put in the holes. Now, I'm going to draw a little circle here. Now, draw it in here, but don't touch the center lines or the edges. It'll snap in a lock-in tangent. You don't want that. So make sure it's just floating there by itself, not touching anything. Click, because you don't want an automatic relationship. Now go to Smart Dimension. Dimension the center point to this edge here, and it's going to be 0.75. And then the center point, remember the little blue cross is what you want to click on when it turns orange. To the top edge, we're just locating this, 0.75. And then the outside of the circle, we're going to make it 0.5. All right. And so with that, now we want to mirror across. Now, you could put them all in individually, and I recommend that in the training guide. But I'm going to show you something a little bit more advanced today. This is something we're going to learn next week, but I'm going to show it to you in advance if you want to try it. Because this is going to speed things up a bit, so you don't have to redraw and dimension that in all 4 corners. Find the line tool and hit the little arrow to the right of the line tool and find center line. Now, find the midpoint here, click, connect it to the origin, click, and find the midpoint over here and click. You really don't have to have it like snap to the actual midpoint, just as long as you align to it and it lines to the origin. It should snap to the origin. Now, I want to show you how to mirror. You can only mirror across one center line at a time. So here's what you do. Select the circle. This after you hit escape on your keyboard. Make sure you hit escape. And that was to get you out of the center line tool. Now select the circle, hold Control. And remember, I released the mouse button. So I'm just holding Control now, not doing both. Select the center line you want to mirror across. So the vertical center line is fine. Doesn't matter whichever horizontal or vertical, not the diagonal ones, because then it will mirror across those. That's going to give you some weird geometry. Okay, so we have both those. Now go up here to Mirror Entities. Click, and it should copy it over. Now let's do that in a little different method. Like we pre-selected the circle and the center line to mirror across. That's the key. Center lines are used to mirror across. Okay. Now, let's say we clicked on Mirror Entities first. This is just a different method using the same tool. Mirror Entities first. Now look at this on the left. The blue boxes indicate fields of entry, where whatever you select on the right by clicking on it, it's going to be entered in there. So select the entity you want to mirror or entities. So the 2 circles, 1, 2. Now you don't have to hold Control if you do this. Now go back over here to the left and click on the Mirror About and make sure it turns blue. Now select the horizontal center line and it will mirror across that. See the preview in yellow? Hit the green check. So now you know you could pre-select the entities or else post-select them, selecting the icon first. So there's always different methods that you'll find in here to do it. I'm not going to show you every single method. I could only show you a handful. You know, you'd have a volume of encyclopedias of all the tools that are in here otherwise. Okay, so we have that done. Now, one of the mistakes students make is they start drawing the internal box. Don't do that. One step at a time. That's a different level. Any different level, if it's not through, should be drawn separately, typically. There are techniques that advanced users use where they do draw it in, but we're going to get to that like in more later dates. Okay, so I'm just going to go to Features, Extrude Boss Base, and this is just one technique, by the way. All right, I'm going to extrude it 1.5 inches, so I type in 1.5 blind, start my sketch. So I click, and we have most of it done. Now I just have to make that little cutout. Now I could make the cutout right here, draw a little box, extrude it through that way, or I could do it on the top. I'm going to do it on the top. It really doesn't matter. Start a sketch on this top surface. Again, use center rectangle, and you have this origin that projected from the original onto the top surface. Click on the origin, drag this to the edge, snap, and now go ahead and let's look at what the dimensions require. So it's 1.5 wide. So you could select the top here if you like. 1.5, and it's done. Now let's cut it. So go to Features, and remember to remove material. You go to Extruded Cut. And we only needed to go 1 inch deep. And remember, we could have drawn it on the side here and extruded it out that way through all. It's up to you. Hit the green check, click, and there it is. It's done. Again, try enhancing it. Go to the Fillet tool if you like. I love fillets and these features because really easily you can make something look genuinely complex and interesting. So I'm going to put in 0.25 fillets. We'll fillet this edge, this one here, use Superman Vision there, click here. I'll increase that a little bit. Let's put some nice big ones on there. 0.55 looks pretty good. Hit the green check. Now we could go and add chamfers. So go in here to chamfer. You could add chamfers to make a countersink. Go ahead and do that. Now, we will learn how to put in a real countersink. I mean, this is a real countersink, but there's actually in the whole wizard. We'll learn about that in the 4th week, exercise 4. But you can put that in like so. Hit the green check. Let's go to Fillet again. Let's set it down a little bit to maybe 0.25. Select this edge here, and maybe these 2 edges here, and here. Hit the green check, and let's try another chamfer. All right, and again, we could shell it. Go to Shell. This is just good practice, not required. Those of you in my classes, just do what the drawing specifies. But I really suggest enhancing it because now you could add different colors to it and the photorealistic rendering and make it look like something outstanding, something great for your portfolio rather than a very simple part. Because the first few parts we do are pretty simple. We will get into more advanced parts as we go through. Like I said, by midterm, you're going to be doing some advanced work. Okay, that concludes this exercise.